few things gave me pause in preparation for the meeting. One is that I would be the second to last of the team talks, and I didn't know what sort of audience I would be getting, but you all seem bright-eyed and bushy-tailed-ish, so good enough. As Don mentioned, we are one of the smaller teams. Officially on my XRP proposal that was selected, these were the team members, myself and Seth Redfield and Mike Endel. The most notable of our other collaborators is Wilson Colley, who's actually the only member of the team who's here. And so he's sort of an official team member now. We added him for NExSS purposes. He's done a lot of great work on some of the things I'm going to talk about. So the title of my team is the Exploring Exoplanetary Exospheres group, which is really a mouthful to say. I like the alliterative quality, although to be honest, if we're being technical, we may not be talking about exospheres, strictly speaking, but more generally extended atmospheres. And so our driving questions are, how do we detect these, and what do they tell us about star-planet interactions? And so there were two things that gave me pause in preparation for the meeting. The other one was Andrew's initial version of this NExSS Venn diagram, which put me right at the center. And only if you have an extremely generous definition of heliophysics is that going to be the case. So I think he rightly made the change to move me more over here. But again, what we are doing is looking at star-planet interactions and how those affect these extended atmospheres. So the driver for this is that in 2012, we made the first detection of hydrogen alpha absorption in an exoplanetary atmosphere in HD 189733b. This is based on some data from the Hobby-Everly telescope down at McDonald Observatory. And why I think this is important is that even though we don't necessarily expect to see this n=2 hydrogen in every exoplanetary atmosphere, the way that we might expect to see a lot of n=1 hydrogen in a lot of hot Jupiter atmospheres, is that at least that we can do this in the visible. And in fact, this was done from the ground. And with, we're not going to have HST forever. It's going away sooner rather than later. So the sort of detections that we've had in the past decade of Lyman alpha absorption around both this planet HD 189733b and 209458, we're not going to be able to make those in the future until we get the next UV capable spectroscope out in space. So so doing this from the ground and in the visible is very very important. So we started this project with several in-hand observations from Keck and the Hobby-Everly telescope. Like I said, Wilson took the lead on the Keck data, and we're still working on a lot of the HAT data. This is some of the initial preliminary results, and you can see that some of it's kind of messy. Basically, we have this is H alpha, or the H alpha region up here for one of our targets. This is the corresponding sodium region. And then this is a calcium, which is essentially our control line. So our control line, which we don't expect to see, is nice and flat. The other two are significantly more messy. That's mostly due to some systematics regarding the tellurics. So again, we don't totally understand what's going on here at H alpha. There's maybe the hint, if you sum this up the right way, there's maybe the hint of some sodium absorption there, but it's far from certain. As far as Nexus activities go, Bill Moore already mentioned that I did give a talk via teleconference to his group, and they had a nice email discussion about our results and what data we might be able to get in the future, and how that relates to what they're doing. I also gave a colloquium at the University of Wyoming. I was invited by Hannah, and she mentioned in her talk the possibility of using WIRO for atmospheric transit spectroscopy, especially as an exploratory tool, because you're not going to be able to do what we're doing here with a 2.3 meter telescope, but at lower resolution, the HD189 detection that I showed is, it's a 2%, has a 2% depth. So even at low resolution, over a couple pixels, you can still get that in a smaller telescope. So if there's other similar planets with that sort of absorption strength, you can get those with a somewhat smaller telescope. Someone just needs to be able to put in the time to do it. So one thing that's hampered us just a little bit is that the HET has been undergoing upgrades for a long time now, and hopefully this year, fingers crossed, it'll be back online. So in addition to finishing up what we're working on now, we'll be able to get some more data. We have Mike Endel from the University of Texas on our team that gets us access to the HET. We did get we did have a K2 program selected, so we have a bunch of targets that we're looking where we want to see if we can find planets around some chromospherically active stars. So I took the RAVE survey, which is primarily in the southern celestial hemisphere, and there's no overlap with the original Kepler field, but there is overlap with some of the K2 fields, and we're looking for targets that have chromospheric activity as indicated by the infrared calcium triplet, and so that's kind of just what this plot is showing, is the Kepler magnitude on the x-axis and the equivalent width of the infrared triplet on the y-axis. And we're still waiting on that data from cycle 3. If we get cycle 4 data, we'll basically triple our sample. May basically put in a similar proposal just for the new fields. And I don't know what happened. What happened there? I think that's a Mac PC conversion error. Sorry about that. So this is, if you can all tilt your heads to the left. This right here, this profile is the H-alpha transit of in HD189 in our follow-up 2013 Keck data. So I kind of saved this to the end. I mentioned it earlier. This is one of the things we were working on this year that Wilson did a lot of work on. And what we found is we confirmed the HET results for H-alpha in HD189733b, and also detected H-beta and H-gamma for the first time. And we also saw a significant pre-transit signal in the 2013 data. And then Wilson went out and got 2015 Keck observations, and we saw again another significant pre-transit signal, but it was very different than the 2013 data. So there's something really interesting going on there, and that's what my poster was about. It's down now, of course, but I kind of have the chronology of what we've seen in HD 189733, and we're looking toward longer-term monitoring of this system to see what we can figure out as far as this pre-transit signal, what it actually means. We've thrown out a few simple models, but then the subsequent data doesn't play nice with the previous models. So anyway, that's what I don't have listed here is that Wilson also brought a separate poster on the radial velocity of the H alpha line. There's some interesting things going on there that I know that he talked to a handful of people about that as well. So if you're interested in either one of those topics, please talk to myself or to him. That's all I have. So thank you. Yeah, let's see. I mean, it's very close to Jupiter size. I don't remember exactly how. I mean, it's within 10 to 20%. I just orbital period is 2 point. Yeah, 2 point. Yeah, that's right.
Pretty interesting observations. So you can probably measure Balmer decrement, which will tell you density. Mm-hmm. That's one comment. It can be done and modeled. And the second question is, have you identified helium lines?
No, we haven't. To do what? To do 10-830. Helium 10-830. Yeah. There's no 5876. Okay, yeah, so just for the recording, Wilson says we have a proposal in to do 10-830 helium line absorption. Okay, thank you.